Welcome to GTech Techno Solution Private Limited. Now we are going to discuss about digital signal processing interview tips with some questions. So the first question is, what is a continuous and discrete time signal? Continuous time signal is nothing but a signal x of t, we can say. So a signal x of t is said to be continuous if it is defined for all time t. Time is represented as t. The continuous time signal arises naturally when a physical waveform such as acoustics wave or light wave is getting to be converted into an electrical signal. This is effected by means of transducer. For example, it might be a microphone or photocell. In terms of discrete time signal, a discrete time signal is defined only at discrete instants of time. The independent variable has discrete values only which are uniformly spaced. Apart from that, a discrete time signal is often derived from the continuous time signal by means of the sampling in it at a uniform rate. You can see the discrete time signal over here. Here we go with the next question. Give the classification of signals. The answer is continuous time and discrete time signals, even and odd signals, periodic signals and non-periodic signals, deterministic signal and random signal, and the final one is energy and power signal. So these are the classification of signals in digital signal processing. This was one such question which is frequently asked and highlighted in Honeywell. What are the types of systems? The answer is continuous time and discrete time system, linear and non-linear system, casual and non-casual systems, static and dynamic systems, time varying and time invariant systems, distributive parameters and lumped parameter systems, and the final one is stable and unstable system. These are the types of systems in digital signal processing. Let's move on to the next question. What are deterministic and random signals? If you see about the deterministic signal, this is nothing but a signal about which there is no certainty with respect to its value at any time. Accordingly, we find that deterministic signals may be modeled as completely specified functions of time. So this is all about the concepts which lies between deterministic signal. If we see about random signal is a signal about which there is uncertainty before its actual occurrence. Such signal may be viewed as group of signals with each signal in the ensemble having different waveforms. Let's move on to the next question. What are energy and power signal? If we consider and see about the energy signal is referred as a signal if and only if the total energy of the signal satisfies the condition. The condition is nothing but 0 lesser than E lesser than infinity. Other than this, the total energy of the continuous time signal x of t is given as E equals to limit t tends to infinity integral x of t into dt. The integration limit from minus t by 2 to plus t by 2. You can see the depiction of energy and power signal over here. If we see about the power signal, power signals are said to be a signal which is satisfying the condition 0 lesser than p lesser than infinity. The average power of the continuous time signal is given by p equals to, p is nothing but the power signal, that is equals to limit t tends to infinity 1 divided by t integral of x 2 into t dt. Integration limit is from minus t by 2 to plus t by 2. So this is all about the power signal. We'll move on to the next question. What are the properties of a system? The first and the foremost property is all about memory. A system is said to be memory if the output signal depends on the present and past inputs. The next property is invertibility. A system is said to be invertible if the input of the system can be recovered from the system output. And the next property is time invariance. A system is said to be time invariant or time invariance we can say if a time delay or advance of the input signal leads to an identical time shift in the output signal. And in terms of the property linearity, a system is said to be linear if it satisfies the superposition principle. Let's move on to the next question. So this was one such question which is highlighted and frequently asked in BSNL interviews. What is memory system and memoryless system? A system is said to be memory system if its output signal at any time depends on the past values of the input signal. Other than this, a circuit with inductors, capacitors are considered to be some of the examples of memory system. If you see about the memoryless system, a system is said to be memoryless if the output at any time depends on the present values of the input signal. An electronic circuit with resistors is an example of memoryless system. Here we go with the next question. So the question is all about what are the time invariant system? If you see over here, a system is said to be time invariant system if a time delay or advance of the input signal leads to an identical shift in the output signal. And apart from that, this implies that a time invariant system responds identically no matter when the input signal is applied. It also satisfies the condition. The condition is over here R into x of n minus k, that is equals to y of n minus k. So this is the condition for the time invariant system. We'll move on to the next question. What is SISO system and MIMO system? A control system with single input and single output is referred to as single input single output system. When the number of inputs or the number of outputs is more than one system, then the system is referred to as multiple input output system. Here we have the next question. What do you mean by periodic and non-periodic signals? So the answer is, a signal is said to be periodic if x of n plus n equals to x of n. Over here if you see, n is nothing but the time period. A signal is said to be non-periodic if x of n plus n is not equals to x of n. Over here you can see the depiction of periodic and non-periodic signals. Let's move on to the next question. Write the expression for order of Butterworth filter. The expression is as follows. Capital N equal to log of lambda divided by epsilon, the whole power 1 divided by 2. Here we have the next question. Write the expression for the order of Butterworth filter. The expression is N equal to log lambda divided by epsilon power 1 by 2, the whole divided by log of 1 by k power 1 by 2. So this is the expression of Butterworth filter. Here we have the next question. What is wrapping effect? For smaller values of omega, that is analog frequency, there exists linear relationship, but in terms of larger values of omega, the relationship is non-linear. The value of omega is all about 2 divided by t tan omega into t by 2. This introduces distortion in the frequency axis. This kind of effect compresses the magnitude and the phase response. This kind of effect is said to be called as wrapping effect. You can see the wrapping effect depiction over here very clearly. We have the next question. Why the impulse response? The question is as follows. Why impulse invariant method is not preferred in the design of IIR filter? IIR is nothing but infinite impulse response. So the question is that the impulse invariant method is not preferred in the design of IIR filter other than the low pass filter. The answer for this question is, in this method, the mapping from S plane to Z plane is many to 1. Thus, there is an infinite number of poles that map to the same location in the Z plane, producing an aliasing effect. It is inappropriate in designing high-pass filters. Therefore, this method is not much preferred. So, this is the reason why the impulse invariant method is not preferred in design of IIR filters other than low-pass filter. Here we go with the next question. What is meant by impulse invariant method? In this method of digitizing an analog filter, the impulse response of the resulting digital filter is a sampled version of the impulse response of the analog filter. So this is all about emphasizing the concept of impulse invariant method. We have the next question. Give the magnitude function of Butterworth filter. The magnitude function of Butterworth filter is magnitude h of j equal to 1 divided by 1 plus omega divided by omega c power 2n power 1 by 2. Here n equal to 1, 2, 3, 4 and it goes on. Let's move on to the next question. How can you design a digital filter from analog filter? If you see, digital filter can be designed from analog filter using the following methods. The first and foremost method is all about the approximation of derivatives. The second methodology is all about the impulse invariant methodology. The third one is all about the bilinear transformation. You can see here the depiction of bilinear transformation over here. We'll move on to the next question. What is meant by FIR filter? FIR filter is abbreviated as Finite Impulse Response. The filter designed by selecting the finite number of samples of impulse response, that is h of n, is obtained from the inverse Fourier transform of the desired frequency response. Over here, if you see, the desired frequency response is represented as h of w. So FIR filter is nothing but the Fourier transform of desired frequency response over the samples of impulse response. Let's move on to the next question. What are the advantages of FIR filter? The linear phase FIR filter can be easily designed. So it can be easily designed is considered to be the first and foremost advantage. Efficient realization of FIR filter exists as both recursive and non-recursive structures. FIR filter realized non-recursively stable. The round of noise can be made small in non-recursive realization of FIR filter. So these are considered to be the advantages of FIR filter. We have the next question. What is the reason that FIR filter is always stable? The reason for the question is FIR filter is always stable because all its poles are at the origin. Here we go with the next question. State the condition for a digital filter to be casual and stable. A digital filter is casual if its impulse response h of n equal to 0 for n lesser than 0. A digital filter is stable if its impulse response is absolutely summable, that is, summation n equal to minus infinity to plus infinity, magnitude h of n is lesser than infinity. Let's move on to the next question. What are the properties of FIR filter? FIR filter is always stable. The realizable filter can always be obtained. FIR filter has a linear phase response. So these are the properties of FIR filter. We have the comparative question over here. Compare the Hamming window with Kaiser window. In terms of Hamming window, the main lobe width is equal to 8p by n and the peak side lobe level is 41 dB. Minus 41 dB. dB over here is decibel. The main lobe width, the peak side lobe level can be varied by varying the parameter A and N. The low pass filter, that is the low pass FIR filter designed will have first side lobe peak of minus 53 dB. In terms of Kaiser window, the side lobe peak can be varied by varying the parameter A. We'll move on to the next question. What is meant by autocorrelation? The autocorrelation of a sequence is the correlation of a sequence with its shifted version, and this indicates how fast the signal changes. Let's move on to the next question. Define white noise. A stationary random process is said to be white noise if its power density spectrum is constant. Hence, the white noise has flat frequency response spectrum. You can see the depiction of white noise over here. Hope the tips was useful for you. Thank you for watching the GTech video.